All right, let's talk Python. We're going to go over 7 super common mistakes that honestly can catch anyone out, whether you're just starting or you've been coding for years. Think of this as your field guide to writing cleaner, stronger code. Let's get right into it.
You know that feeling? You've written some code, it runs, everything seems fine, but there's this little voice in the back of your head going, is this thing gonna break later? Well, a lot of these mistakes are exactly why that happens. They're these little time bombs just waiting to go off at the worst possible moment.
So first up, we're going to tackle the basics, syntax and style. These are the kinds of mistakes that have to do with how your code is structured and how it looks, which in Python are pretty much the same thing.
And that brings us to number 1, a classic rite of passage for every Python programmer, the indentation trap. See, in a lot of other languages, white space is just for making things look pretty. But in Python, oh no, it defines the entire logic of your program.
And this image of the snake, it's just perfect, right? That's your code when the indentation is off. It literally tangles itself up. If your code blocks aren't lined up just right, the whole structure, the logic of your program can just completely fall apart. And trust me, hunting down a bug caused by a mix of tabs and spaces, it's one of the most frustrating things ever.
The fix is all about consistency. It's that simple. On the left, you see what happens when you mix spaces and tabs. Boom, a syntax error. On the right, the solution is just to pick a standard and stick with it. The community standard, by the way, is 4 spaces for each level. It's clean, it's simple, and it just works. Okay, let's jump to mistake number 3, which is another one in the style category, completely ignoring PEP 8. PEP 8 is Python's official style guide, and honestly, following it is often what separates professional code from amateur code. I love this analogy. Writing code isn't just about telling the computer what to do. It's about writing something that you can understand 6 months from now, or that your teammates can understand today. Following PEP 8 is like keeping your workspace tidy. It just makes life easier for everyone.
And here's the proof in the pudding. I mean, the code on the left works, technically, but what on earth is it doing? The code on the right, which follows PEP 8 with clear names and good spacing, tells you the story instantly. This isn't just a suggestion. It really is fundamental for writing software that lasts.
Okay, let's get a little deeper now. Our next section is all about data and memory mysteries. These are the sneaky, subtle bugs that pop up when you don't quite have a handle on how Python is managing information behind the scenes. Which brings us to mistake number 2. And believe me, this one is a huge gotcha: mutating default arguments. If you've ever put an empty list as a default value in a function definition, there's a good chance you've been bitten by this and might not have even known why. Okay, this magician's hat visual is brilliant for explaining this one. Here's the deal. In Python, when you set a default argument like an empty list, it gets created only one time when the code is first read. So that default list is like a single hat that the magician never empties. Every single time you call that function, you're not getting a fresh new list. Nope, you're using the same exact one from the last call. And that leads to some very weird and unexpected results. So what's the right way to do it? It's this pattern you see on the right. You set the default to none, which is safe. Then, inside your function, you just check if the argument is none, and if it is, you create a brand new list right there. This guarantees every single function call gets its own fresh start, and you completely avoid that weird shared bug. All right, next up in our tour of memory mysteries is mistake number 5. Getting is and the double equals equals mixed up. They look similar and they both have to do with equality, but what they're actually checking is fundamentally different. So let's break it down real simple. Double equals checks if the values are the same. Imagine 2 different wallets that both have $20 in them. Their values are equal. The is operator, on the other hand, checks if they are the exact same object. Is it the very same wallet? That's object identity. These treasure chests make it super clear. You could have 2 chests that contain the exact same amount of gold. They have equal value, so double equals would be true, but is asks a different question. Are they the same physical chest? That's identity. The general rule of thumb? Use double equals for comparing values, and really only use is when you're checking against singletons like none. Okay, time to shift gears and talk about how we control the flow of our programs. This section is all about flawed logic and loops, some really common ways we can trip up when directing our code and handling things when they go wrong.
And we'll start with mistake number 4, the loop variable leak. Now, to be fair, this is mostly a thing of the past from Python 2, but understanding it is so important for grasping the concept of variable scope, which is absolutely still critical today.
This little lizard hopping off the track is a fantastic metaphor. Back in the day, with older Python versions, the variable you used in your for loop, like the I, would just hang around after the loop finished, holding onto its last value. It leaked out. Thankfully, Python 3 fixed this for us, but it's a great reminder to always be aware of where your variables live and for how long. Moving on to mistake number 6, and this is a big one. You see this in a code review, it should be a huge red flag. Catching exception blindly. This is when you use a really broad try-except block that just swallows every single error. And that is a dangerous game to play. Writing except exception is like throwing this giant net into the ocean. Sure, you'll catch the specific fish you were hoping for, but you're also going to catch old boots, seaweed, and maybe even a critical system error that you really needed to know about. The key is to be specific. Use a smaller net. Catch the specific value error or key error you're actually anticipating, and let the other unexpected errors rise to the surface. It's the only way to know what's really going wrong. Okay, for our last section, let's move beyond just fixing bugs and start talking about leveling up our style and performance. We're going to talk about the path to efficiency and how to write code that feels truly Pythonic.
And that brings us to our final mistake, number 7, not using list comprehensions. Now, this isn't really a bug, it's more like a missed opportunity. A chance to write code that's more elegant, easier to read, and, a lot of the time, faster.
I absolutely love this visual. Building a list with a traditional for loop is like this slow, clunky conveyor belt. I mean, it gets the job done, one piece at a time, but a list comprehension, that's the bullet train. It's fast, it's sleek, and it expresses the whole idea in one powerful, self-contained line. And here's the side-by-side. The proof is right here. On the left, you've got your standard, perfectly fine 4-line for loop to create a list of squares. But look at the right. The list comprehension does the exact same thing in one single line. And it's so much easier to read. It basically says exactly what it's doing. Give me x squared for every x in this range. It's just cleaner. This really is the whole story right here. Once you get comfortable with them, list comprehensions feel like a superpower. They are one of the hallmarks of a developer who really gets Python and knows how to use its strengths. So after all that, what are the big ideas to walk away with? Well, it really boils down to a few things. 1, always choose clarity over being clever. 2, really take a minute to understand how Python's data types and memory actually work. 3, be specific with your logic, especially when you're handling errors. And finally, you've got to embrace the tools that make Python so great, like list comprehensions. So as we wrap this up, I want to leave you with a question. Now that you've seen these 7 common traps laid out, what's the first thing that popped into your head about your own code? Go take a look at one of your projects. What's the first fix you're going to make to build stronger, cleaner code? Thanks for tuning in.